This is Dr. Mark Barkey, and this is a video for my class, Applied Finite Element Analysis, AEM535. This is kind of a redo of a video I made a few years back where I took a look at a Schedule 80 pipe. And so what we're going to do, since Hypermesh has kind of been updated a little bit, Abaqus has been updated a little bit, there's some things I want to change in some of the videos, maybe update that. I'm going to go ahead and reshoot these videos for both Hypermesh and Abaqus. This first one will be for Hypermesh. And I found a Schedule 80 pipe chart, and the one that we're going to do is we're going to build in Hypermesh a mesh for the 24-inch Schedule 80 pipe. So it's going to be this one down here. So if we look at these dimensions, it has an OD of 24 inches, and it has a wall thickness of 1.125 inches. So if I can kind of show that on a plot, kind of maybe a cross section, if I can make a couple circles here. And this won't be to scale, but give us kind of an idea of what's going on. What we have then is our outside get back to free drawing instead of circles. Our outside radius, then this dimension here, will be 12 inches. And then our inside dimension is going to be 12 minus the wall thickness of 1.125. And let's see what that is. (10.875 inches). So we'll make this mesh in Hypermesh. And for a section of pipe, let's go ahead and let's make it 36 inches long. And what I'm going to do is I'm going to first mesh the cross section, then I'm going to drag that through down the z-axis to make this section of pipe. We're going to apply a simple tension load on it. We're going to over constrain one edge, and we're going to see why that's probably something that we don't want to do. We're going to relax the constraints and set up a local coordinate system in Abaqus so that we do R and theta constraints. We're going to do Z and theta constraints. We're going to allow it to freely expand or contract in the R direction. And we're going to see that we get a much cleaner uniform stress distribution. After that, we're going to apply a internal pressure to our pipe and see what stresses we get with that. And as part of this, we're going to take a look at verifying our results with mechanics of materials, our deformation or displacement calculation of the end of the pipe, the change in length of the pipe, and also with our thin-walled pressure vessel theory. All right, well, let's get into Hypermesh first. So in this case, we're using Hypermesh 2022, and I am on our VPN. There have been a few updates in Hypermesh. For the most part, I haven't found any particular issues with it. I should pop up here a little bit more detail here in a moment. It's still kind of working on it. But again, I really like Hypermesh. It's great for building meshes. It can do its own finite element analysis, and there's other things that Hypermesh can do, and HyperWorks and kind of work together. But we'll see that it's a pretty good option with Abaqus. In some cases, we want to build our mesh directly in Abaqus. In some cases, we can take something, mesh it in Hypermesh, where I think, in my opinion, I have a little bit more full control over what's going on, and then bring that in here. So let's see, it comes up with this. I want to make sure that I've chosen Abaqus as my application that I'm going to use, and I'm going to do standard 3D. All right, I'll leave that checked, always show it startup. So if you use ANSYS or LS-DYNA or something like that, it can make accommodations for those element names and so forth. You can do a lot of sophisticated things in Hypermesh. We're going to do just the basics so that we get an mesh and import it into Abaqus. And in fact, at the end of this, I'm going to give you the mesh that I create so that if you just want to watch this video and you're having trouble with Hypermesh, that's fine. You don't have to necessarily use Hypermesh yourself for this particular homework set. All right, so I'm going to hit OK. And here we have this. This is kind of different. This is a session. Okay, then it has mask and it has model. Okay, I'm going to click on the model over here, and I'm going to create a component. Now, having some experience with Hypermesh, I kind of know what I want to do. I'm going to create a couple circles, and we're going to mesh in between the circles to create a plane of two-dimensional elements. Then we'll drag that plane down the z-axis. So with that in mind, I'm going to call my first component circle. I'm going to go here to geometry. I need somewhere to start. I'm going to start with a node at 0, 0, 0. Create it. It did pop up. It popped up way down here. To kind of center that, what I'm going to do is I'm going to hit this fit model. Okay, and I moved it right over there. There are some weird cases where I've seen in past versions of Hypermesh, and maybe it's fixed now, the nodes just did not show up. Some graphic cards issue. There are some ways around that. If you have that error, put it on Google, ask me on our discussion board, see what we can do to kind of help with that. Everybody's computer is different. I don't always get the same errors that everybody else does, so do keep me posted with the error, but also try to look for a solution. All right, so we have a node that's sitting right here. I'm going to return out of this menu. I could put more nodes in if I want. In this node, don't think of it necessarily like a finite element node. It could be, but this is a node that's going to help me construct a couple of circles. So I'm going to go here to geometry, and a circle is a special kind of line. So I'm going to go into the lines, and then here's the different ways I can do lines, and one of them is a full circle, which uses a node list, and you might see all these different options here, and 1 and 2 and 3 might be the first thing that pops up. Okay, so I'm in the XY plane, and so I want to make a circle that is perpendicular to the z-axis. My node list is the center of my circle, and my radius is going to be, well, I said radius was going to be 12 inches, so I'm going to create that. And I hit create. I don't see anything. Well, I need to fit it. Okay, so there it is now that it's fit. I'm going to create a circle that represents the inner surface. And we said that was going to be at, I believe we said 10.875. I need to reselect my node, put in a new radius, and then I'm going to hit create. And now I have my second one there. I have what I need, so I'm going to hit return and get out of here. All right, so let's see. Now I want to mesh in between these two lines. It's going to be a 2D mesh, so I'm going to go to 2D. I'm going to use the option ruled, and I'm going to select one line for my first line and the second one for my second line. And there's going to be some options here. We can mesh and keep a surface. We can mesh and delete the surface. We can mesh without a surface. We can only make a surface. So what a surface is in this program is it's an entity that allows you to remesh it very quickly for new elements. So if you create a surface, you can come back later and keep that surface and then change your mesh on that surface however you want. My preference here is just a mesh without a surface. So we're going to just put some elements on here. We're going to see what it looks like. So now that we got these things selected, I'm going to hit create. And there's its initial proposed mesh. That doesn't look like a circle to me. So we're going to change some of these numbers. Now, there's two ways you can change these numbers. You can click on these buttons. It says 7 right here. And it will change the number of elements along this way and along the circumference along this circle. Now we can recalculate with an element size. What I'm going to do is, since there's 360 degrees in a circle, if we go every 5 degrees, that would be 72 elements around the circumference. So I can set all to 72, and that would do that. But now we have 72 over here. So what I'm going to do is I'm going to leave these two as 72, and I'm going to say let's have 5 elements on this particular edge, and change that number to 5. I'm happy with that. I'm going to hit Mesh. Now before I do, I want you to see how if we only have very few number of elements, we're not really capturing the curvature of the pipe. We're not capturing the geometry of the pipe accurately. Okay, so that's 7 elements, but now if we have 72, let's see if we're a little bit better here. So I'm going to hit Mesh, and it looks like we're a lot better. So I'm pretty happy with this mesh. I'm going to hit Return. If you don't like it, you can go abort, and you can do different options and so forth. But I kind of like mine, so I'm going to hit Return. Now I'm going to assume that when I bring this into the teaching edition of Abaqus, which is what we're using for our class, that we have enough nodes and elements to be able to do this analysis. If it turns out that we have too many nodes and elements for the teaching edition, we're going to try something different. I think this will work. If you have the student edition, which is free, you may not have enough nodes and elements, so you may need to adjust your mesh appropriately. All right, so let's zoom in on this. Now we saw the kind of what we call the discretization error of the geometry, but it's possible that we might still have some discretization error. So let's kind of really get in on this. And these are different, these are the same color, so it's kind of hard to see exactly what's going on. But you see the circle, and then you see the elements. So to me, like on this edge right here, the part of this is not capturing the inside edge of our pipe quite as accurately as what we might expect. So I would think that this is the circle, the line for the circle. Let's turn the geometry off. Turn the geometry off by coming over here, toggling that button. Okay, so in some of these cases, the discretization, the representation of our model isn't exactly the perfect circle that we think it is. Now that can come into an effect on our results. And we can check for that. But remember, whenever we're doing a finite element analysis, there's lots of different errors that creep in. One is how accurately are you representing your geometry system. All right, we'll worry about that a little bit more later in the semester. All right, so I have this, and let me fit this. If I want to rotate this in space, these are these buttons here. And if you notice, I'm kind of in the Y going up, X to the right, and Z coming out the page at us. What I want to do then is I want to take this mesh, I want to create three-dimensional elements by dragging it down the Z axis. So I'm going to get out of this. I'm happy with that. And I need to be a little bit careful. I don't want to make this mesh inside my current component. Sometimes they call them collectors. I don't want to make it inside my current component, so I'm going to create a new component. So I'm going to right click and hit create component, and I'm going to call this one pipe. And if I don't like that color, I can change it, and maybe I want to make it some kind of bluish color like that. Maybe that's too blue. Let's make it an orangish color. All right. Now you see that this has kind of turned into bold. That means that is your current collector. So if I make, or component, if I make a new mesh, the mesh will be in the collector or component pipe. If I want to do something more in circle, I'm going to right click on that and I can make that the current one. But here I want to make the pipe current. So now I'm going to go into the 3D panel, and I'm going to drag the elements that are displayed. Could go by collector or component. Okay, so I could go by collector and select that. And then I'm going to have a distance of 36. I'm going to put 36 elements in the 36 inches. I'm going to drag it. And I'm going to drag it down the z-axis. So I could go the x, y, whatever, go off at some weird vector. I'm going to go to the z-axis, and the elements are going to go into the current component, which is the pipe. So let's see what happens when I hit drag plus. Okay, it dragged it down the positive z-axis. If I want to see what this looks like in more of a shaded thing, I'm going to hit this button, and that will shade that out. Let's fit this to the window, and I'm going to click this rotation button to kind of look at it. Okay, so here are my original plane of two-dimensional elements. There's my temporary node that I use for my reference. And then I have my pipe that I just created. Okay, so as we go through our class, we're going to take a look at things that make good elements and things that may not make good elements. Let me turn off the circle, and I'm going to turn off the 2D mesh. Now all we have are 3D mesh elements here. And let's kind of get in on this just a little bit. The more square your element, the better quality your element is going to be if it's a 4-noded element. If you have a brick element, like an 8-noded element, then the more cube-like, kind of the better you are. Now these have a certain aspect ratio. They're kind of square in the plane. If I look at that this way, they're a little bit thin. I don't think that's going to cause us any problems. All right, let's turn this mesh off, and I'm going to turn the surface off. And let's go back to the surface, and let's go back to there. Hit return. Now, I want to highlight the circle. I want to show you, talk about something else here. I want to highlight the circle. I'm going to create one more component. And I'm going to copy my two-dimensional elements into that. Now here's some advice if you use this software with Abaqus. Try not to start your component with a name that starts with a number or anything weird. Use a letter, A through Z. Also, try not to put any spaces in your component name. You'll be better off when you use Abaqus later. If you do those things, you won't have any problem. So what I want to do is I want to move my mesh that's in circle. I want to move it to copy 2DLs. I'm going to go to Tools. I'm going to organize elements that are displayed. And my destination component is going to be copy 2DLs. And I'm going to move them in there. So now when I turn off the elements in circle, they're not there anymore. Geometry is inside circle. Can zoom in on this. The elements are now in the new component. So I meant to move and not resize. So I can turn those off, and I can see those in a different color than I see this. Again, let's zoom in a little bit on the circle so we can see this error in the approximate geometry. Now, there are such things as if we were doing brick elements, we would have an 8-noded brick, which is a node at each corner. But there are higher order elements that we could use as well. Higher order elements can result in more accuracy for the same physical sized element. So instead of an 8-noded brick, we can have a 20-noded brick element. They have nodes along their mid sides as well as all their corners. And in that case, those are called quadratic elements. We could have a better curve, we could have a quadratic shape to the element between this node and this node over here. And that may better suit this kind of curved geometry. So that's one thing that we can do to kind of help this error out a little bit. For our purposes, if we always zoom in, we'll always find some kind of mismatch between our perfect line and our elements. In fact, if we keep zooming in far enough, even our perfect circle is going to stop looking like a circle. There are definite limits on the representation of what we have in our computer. All right, so let's turn this off. Let's go back to the pipe. Let's turn our lines off. And another thing that we need to do is, if you notice, there's kind of this odd looking dark line right here. Now what happened when we created the 2D mesh is that this spot right here was, remember, this was the place that had all those numbers on it. And we said we're going to change this to 5. The default was like 1. What it does when it created this mesh is it went from the inner radius to the outer radius and did 5 elements. But on the way around, it's kind of like it started here and it stopped here. So if we were to really look at this, there are duplicate nodes in that spot. Now if you want to see the node numbers, what you can go down to is Tools, go to Numbers, Nodes, and I'm going to go by Window. And I'm making a little window here. I'm going to select those entities. I'm going to press the button on. And this might be kind of hard to see. Refit this. But if you look at this number right here, you can't hardly read it because there are actually 2 numbers sitting on top of each other. Node number, whatever, whatever. And then at the same spot, there's also a node that has a different ID, different number. What happened when we had to drag these elements down the z-axis is we created an entire plane of duplicate nodes. Let's turn these off. Turn out of here. Turn off my 2D elements. Turn on the 3D elements again. Let's fit it. So all of these things are duplicate nodes. Let's go back to being able to see through the mesh. And you can't tell on this view, really. I can't. So whenever you have a mesh in Hypermesh, what you should do is you should go through and check your edges and equivalence your mesh as needed. So that's what we're going to do on this spot. So I'm in the Tool menu. I'm going to go to Edges. My component is going to be the 3D pipe. I'm going to select that. Here's my tolerance. Whatever your units are, 0.01 units. If you have 2 nodes within 0.01 of one another, it's going to try to equivalence them. Now you could really mess up your model if you make this thing too big. At the same time, you don't want to make it too small. All right, so let's go first, and we're going to find edges. Okay, now it created a new component called Edges. Let's turn off our pipe. And you can really see the edge that it created because of those duplicate nodes. So this is almost like a split in this pipe. The 2 edges here on the inner and outer radius on both ends, that would be expected. But this plane right here is a problem. Okay, let's turn off the edges, turn back on the pipe, and we're going to go Preview Equivalence. I need to select my component again. Preview Equivalence. And so all of these nodes on this plane have just been highlighted. Zoom in on this just a little bit. And we can maybe rotate this around. So all of those are duplicate nodes. We don't want to have duplicate nodes. In a finite element mesh, if you were to pull on this pipe or put some pressure on the interior of this pipe, we'd split open that pipe like a crack, because it doesn't think that those elements are connected to each other. All right, so what I'm going to do then is I'm going to I'm going to equivalence this, rather, hit equivalence. Now, if I go to find my edges, I should still have that component selected. It's highlighted in blue. Refit this. Turn off my pipe. Now look at my edge. I don't have that weird edge anymore. All right, the next step then is we're going to export this mesh so that we can bring it in to Abaqus CAE. Happy with this, I'm going to hit return. Now before we export the mesh, I'm going to turn off everything I don't need and only turn on the elements that I want. Now we do have an extra node that's floating around that helped me build those circles initially. I'm going to get rid of that. I'm going to go to Geometry, Temp Nodes, and we're going to clear all the temporary nodes. And so now I got rid of that. All right, I'm going to save this before I make too many more changes. And I always recommend making multiple saves as you go through a model. Okay, so you can save your session, which is kind of new, or you can save your model. I'm going to go Save Model. This will save it as a Hypermesh model. I practiced, so there have one right there. And for me, I tend to like to put the date in things. So this is 2022, August the 28th, 220828. Maybe some kind of description. Pipe number 1. Let's see, how about let me do this. Pipe dash HM for Hypermesh. And then here's my version. Now, I did do a version earlier, so instead of 1, I'll call it V2. It's going to save it as an HM file. It's going to save it in this folder that I have specified here. All right. Now I'm going to export this model. And there are some things you need to watch out for your export. Now to export, I'm going to go up to File. But before I do that, I want to have displayed only what I want to export. And I'll explain why that is. So I only have the pipe on. I see I turned on the 2D elements just for a moment. But I only have the pipe turned on now. I'm going to go to File. I'm going to go to Export. I'm going to export a solver deck to Abaqus Standard 3D using that template. This is going to be the location of that. And I'm only going to export what is displayed. Now this is version 2 of my pipe. I practiced ahead of time. So I'm going to label that as D2. Let me get rid of that dot. I think I'm good. Now I'm going to go ahead and hit Export. And you see it flash real quick, your nodes and your elements. All right, so with that, let's take a quick look at this file, and then we'll see what happens when we import that into Abaqus in the next video. Get rid of that. I'll get rid of this. This is where I put it. Bring this over here to this screen, and there should be here it is, pipe-v2.inp. We talked about using Crimson Editor. So I'm going to open that file with my Crimson Editor. You can use Notepad++, what have you. And you have to be a little careful with Crimson Editor. If you had a previous analysis or previous text file loaded into it, it'll load that. So I'm going to close that one, and here's what I want to look at. So these are my nodes. Okay, if you're not familiar with a node, it is a point that has been defined in your model. That's the node number. And these are the three-dimensional spatial coordinates of that node number. There's a whole lot of them. There's a lot of digits here. Scroll down, you see it kind of changed. Let me see if I can find the spot where it changed. And then these are the elements. So the first one is the element number, and the element is composed of, since it's three-dimensional, 8 nodes. So 1, 2, 3, 4, 5, 6, 7, 8. So those 8 nodes compose the corners of this particular element. The element type is called a C3D8R. We'll learn more about those, but this is a continuum element for the C. It's a three-dimensional, 8-noded reduced integration element. The default is fine for us. Now, when we bring it into Abaqus and we save this as a job, you'll see there will be a lot more things added to this file to make an input file that Abaqus will be able to use. Right now, this is just the nodes and the elements. All right, so with that, I am going to stop this video, and we can bring this into Abaqus in just a moment.